Hello my dear friends, welcome to my YouTube channel. This is Dattu Patel, Assistant Professor from LJIT. Earlier lecture, we are already discussed about the ratio test and rub-based test. Today's session, we are going to discuss about the Cauchy root test and Leibnitz test for alternating series. Let's see. First, we have to check the Cauchy's root test. If summation where n is running from 1 to infinite, un is a series with positive terms and where un not equal to 0 and limit n tends to infinite, mod of un raised to 1 upon n. That means nth root of un is equal to L. Here value of limit which is lies between 0 to 1, that means 0 less than or equal to L less than 1, then we can say that given series sigma un is convergent. Value of limit which is greater than 1, then the given series is diverges. If value of limit which is 1, then we can say that Cauchy root test is fail, means root test does not give any information about the convergence or divergence. Firstly, we have the arising question in our mind, how we can identify root test is applicable. Means our un is in form of something raised to n, then we have to apply the root test of that particular sum. Let's see the examples of the based on root test. Test the convergence of this series summation n equal to 2 to infinite 1 upon log n raised to n. Here un has a something power raised to n, then root test is applicable. Here un equal to 1 upon log n raised to n, then nth root of un, that is 1 upon log n. Now applying the limit n tends to infinite to the nth root of the un, then limit n tends to infinite 1 upon log n. Now apply n as a infinite. You all are aware about the value of log infinitive, that is infinitive, then 1 upon infinitive, that is 0, which is less than 1. Then according to the condition of the root test, if limit which is less than 1, then we can say that given series is convergent. Now let's see check out the one more example. Is the series summation n equal to 1 to infinite n e raised to n is convergent. Here un equal to n e raised to n. Now nth root of un, then un raised to 1 upon n equal to n e raised to n raised to 1 upon n. Now applying the limit n tends to infinite to the nth root of un, then it becomes e into limit n tends to infinite n raised to 1 upon n. You all are aware about the limit n tends to infinite n raised to 1 upon n equal to 1. That is the standard limit which is already discussed about the last lecture of this sequence. Then value of limit n tends to 1 upon n, that is 1, then substitute it, then we get e into 1. Here normal value of e, that is 2.718, which is greater than 1, then we can say that given series is divergent. Now let's see one more example. Test the convergence of the series 1 cube by 3 plus 2 cube by 3 square plus 3 cube by 3 raised to 3 and so on. In this type of particular series, we don't have n term of the series. Then first we have to find n term of the series, which is un. That un equal to n cube by 3 raised to n. Means first term has a 1 cube, 2 cube, 3 cube, 4 cube and so on. Then we write n raised to 3. Denominator portion has a 3, 3 square, 3 cube, 3 raised to 4 and so on. Then we can write 3 raised to n. Now applying the nth root of the un, then it becomes n cube by 3 raised to n raised to 1 upon n, and simplified this and applying the n as a infinite to the nth root of the un, then it becomes limit n tends to infinite n raised to 3 by n divided by 3. Here 1 by 3 which is constant, then comes out the bracket, and limit n tends to infinite, we can write n raised to 1 upon n whole raised to 3. You all are aware about the value of limit n tends to infinite n raised to 1 upon n, that is 1. Substituting this one, then we get our limit, which is 1 by 3, which is but obvious less than 1. Then according to the condition of the root test, we can say that given series is convergent. Now let's see the next topic, which is alternating series. If its terms are alternatingly, means positive and negative, then we can say that a series is alternating series. That means first term which is positive, then negative, positive, negative, and so on. This type of series we can say that it is alternating series. For example, 1 minus 1 half plus 1 by 3 minus 1 by 4 and so on. Now let's see the next topic, which is Leibnitz test for the alternating series. If the alternating series summation n equal to 1 to infinite minus 1 raised to n minus 1 un, now substituting the n equal to 1, 2, 3 and so on, then it becomes u1 minus u2 plus u3 minus u4 and so on. Then it satisfies two conditions where un greater than 0. First condition, which is un plus 1 less than un for all n, or we can say that un which is greater than un plus 1. That means each term is numerically less than its preceding term. Second condition, limit n tends to infinite un equal to 0. Then the given series is convergent. Firstly, whenever we apply the Leibnitz test, means we have the question such type of alternating term, means alternating whenever our term in form of alternating series, then we have to apply but obvious one and only Leibnitz test. Now let's see the example based on Leibnitz test. Test the convergence of the series n equal to 1 to infinite minus 1 raised to n plus 1 upon log n plus 1. Here given series is alternating or not, then we have minus 1 raised to n plus 1, and substituting the n equal to 1, 2, 3, 4 and so on, then we get positive, negative, and so on. Here given series is a alternating series with un equal to 1 upon log n plus 1. Log x is a increasing function, but here reciprocal of the increasing function means 1 upon log n plus 1. That means our series is decreasing form. Here must be condition is a first condition, which is each term is numerically less than its preceding term, means our series in form of decreasing form. And second condition, which is limit n tends to infinite un equal to 0. Let's see first condition. And denominator portion has a log n plus 1. Next upcoming term, which is log n plus 2, then log n plus 1, which is obvious less than log n plus 2. Now reciprocal of that particular term means that implies 1 upon log n plus 1 greater than 1 upon log n plus 2. That means un which is greater than un plus 1, or we can say that un plus 1 which is less than un. That means each term is numerically less than its preceding term. First condition will be satisfied. Now secondly, limit n tends to infinite to the un, the limit n tends to infinite 1 upon log n plus 1, n as a infinite, then it becomes 1 upon infinite, that is 0. Therefore the given series is convergent by the Leibnitz test. Now let's see the one more example. Test the convergence of the series 1 minus 1 upon 2 root 2 plus 1 upon 3 root 3 minus 1 upon 4 root 4 and so on. In this type of series, we does not have n term of the series. So firstly we have to find nth term, and here first term positive, second term negative, third term positive, then we can say that given series is alternating. If our series is alternating, then we have to apply only one and only Leibnitz test. Then here our in general form series becomes summation n equal to 1 to infinite minus 1 raised to n minus 1, 1 upon n root n. Here un equal to 1 upon n root n. Now substituting the n as a n plus 1, then un plus 1 equal to 1 upon n plus 1 square root of n plus 1. Here with the help of inequality, n root n which is less than n plus 1 root n plus 1. Here we applying the reciprocal of that particular term, that implies 1 upon n root n which is greater than 1 upon n plus 1 square root of n plus 1. Here un which is greater than un plus 1. That means each term is numerically less than its preceding term. Means our series is in form of decreasing form. Then secondly, limit n tends to infinite, un equal to limit n tends to infinite 1 upon n root n. Then n as an infinite, then it becomes 0. Then according to the Leibnitz test, we can say that given series is convergent. Now let's see the summary of the infinite series. Firstly, how you can identify such kind of example, which type of method you can applicable to solving the problems. Then firstly, suppose we have the question in form of 1 upon n square, 1 upon n cube, 1 upon n, that type of particular question, then but obvious we apply p series, that is summation 1 upon n raised to p. Here value of p which is greater than 1, then it is convergent. Value of p which is less than or equal to 1, then it is divergence. Secondly, suppose we have the question 1 plus 1 by 3 plus 1 by 3 whole square plus 1 by 3 whole cube and so on, means which is geometric series, means our series which is in form of summation a r raised to n minus 1 or a r raised to n, where a not equal to 0. Such kind of example we can apply geometric series, and this particular series value of r which is lies between minus 1 to 1, then it is convergent. And other than means mod r greater than equal to 1, then we can say that given series is divergent. If you can see a glance that limit n tends to infinite, un not equal to 0, then it is applicable for the zero test, or we can say that test for divergence should be used. Now, if the series in form of similar to p series, or we can say that our series which is in form of rational function or algebraic function of the involving the roots of polynomials form, that means different power of n in numerator and denominator portion, like as n square plus 1 upon denominator portion has a n raised to 5 plus n square plus 1 plus 3 whatever, this type of question, then we are applicable to the comparison test for solving the such kind of example. If the series which is in form of minus 1 raised to n into un or minus 1 raised to n minus 1 into un, means it is alternating series. If it is alternating series, then but obvious one and only possibility to solving the example, which is Leibnitz test for the alternating series. Suppose we have the example which is based on factorial form, which n factorial, n plus 1 factorial, 2 factorial, or we can say that constant raised to n. This such kind of example given to you, then but obvious we are going to solve this type of example with the help of D-Albert ratio test. If un is in form of something raised to n, means whole bracket raised to n, then we have to apply the root test. If un equal to f of x or f of n, where we can easily calculate integral 1 to infinite f of x dx, then the integral test is very effective to solving the such kind of example. If you have any query regarding this topic, then feel free contact me. I hope you guys, you all are learned something this video. If you like this video, then thumbs up. If you think that this video will help some of your friends, then do the share with them. If you want to watch more tutorials like this, then you can subscribe my channel. Whenever I upload the new video, you get the notification. Thank you so much for watching me.